Hello students, in today's video we're going to learn about scalar and vector quantities. Before we start with that, let's first understand what are physical quantities. All physical quantities consist of a numerical magnitude and a unit. For example, mass of an apple is 300 grams. The mass is the physical quantity. The value of 300 represents the numerical magnitude, or the amount of mass. Gram represents the unit of mass. There are two types of physical quantities, scalar and vector. Scalars are physical quantities that only have a magnitude but no direction. And remember, magnitude is just another way of saying size or amount, and so it can be measured with a numerical value. For instance, if a car travels at 20 meters per second, 20 would be the speed's magnitude, considered a scalar since speed lacks direction. Other scalar quantities include things like distance, mass, time, and volume. Vectors, on the other hand, have both a magnitude and a direction. For instance, if a car travels at 20 meters per second in east direction, 20 would be the magnitude. East would be the direction. These include things like force, displacement, velocity, and acceleration. Don't worry if these terms are unfamiliar. We will discuss each one of them in detail in upcoming videos. To help you understand the difference between scalars and vectors, envision starting at point A and walking a distance of 2 kilometers. Depending on which way you set off, you could end up in any direction, which is why it's a scalar quantity. This is because distance doesn't actually give us any idea of the direction, which is why it's a scalar quantity. However, if you'd started at A and then told us that you walked 2 kilometers west, we'd know exactly where you ended up, because you gave the exact displacement, which is a vector quantity, because it has both a magnitude of 2 kilometers and the direction of west. If you say you walked 4 kilometers in the north direction, then we would represent it something like this. If you notice, the 4 kilometers arrow is represented bigger than the 2 kilometers arrow because in order to represent vectors, we use arrows with the length of the arrow, indicating the magnitude of the vector, and way it is pointing gives the direction. Consider another example. Simply stating a force of 10 newtons applied to a block does not provide a clear picture of its expected movement. However, specifying a 10N force applied eastward will result in the block moving in that direction. Similarly, a force of 10 newtons upwards will lift it off the ground. Therefore, in vector quantities, both the magnitude and direction are equally crucial. In the upcoming videos, we will be covering various important terms related to motion like distance, displacement, speed, velocity, and acceleration. So, stay tuned and see you next time.